Generating clean, renewable energy right from your own property has never been more accessible, and understanding how a complete, off-grid, or hybrid solar power system works is the first step. To illustrate this process, let's explore the setup shown in image_0.png, which breaks down the entire energy flow from sunlight to your household appliances. This specific configuration is a powerful and efficient design, engineered to provide reliable electricity. At the very top of the system are the primary power generators, 3 250W solar panels, for a total peak capacity of 750 watts. These are high-efficiency photovoltaic PV modules, each carefully positioned to capture maximum sunlight. Notice that they are connected using specific multi-contact MC4 connectors, with clear plus positive and dash negative markings. The specific wiring in image_0.png shows the positive terminal of one panel connecting to the negative of the next. This creates a series connection. What does that mean for performance when you connect solar panels in series? You add their voltages together. Let's say each 250W panel has a nominal operating voltage of around 30 volts. Connecting 3 in series means the total system voltage being output by the array is roughly 90 volts. This higher voltage is crucial for efficient power transmission over distances and for enabling the charge controller to operate at peak efficiency. However, the system current amperage remains the same as that of a single panel. This design is excellent for high-efficiency charge controllers, like the MPPT model seen here. The first critical safety feature is the connection from the positive terminal of the last solar panel in the series. Instead of going straight to the core electronics, the current flows through an MCB, or miniature circuit breaker. The MCB is an indispensable component, acting as a safeguard for the entire system. Think of it like the main fuse in your car's electrical system, but resettable. Its green switch handles can be flipped to on or off. Its primary job is to detect abnormally high current, perhaps due to a short circuit or an unexpected power surge, and immediately trip, cutting off the current from the solar panels. This protection prevents damage to the expensive charge controller and other downstream components. In image_0.png, it isolates the positive line, which is standard practice. Following the MCB, the current reaches the heart of the operation, the solar charge controller. The specific model shown in image_0.png is advanced and highly featured, evidenced by its digital display and several control buttons. This isn't just a simple on-off switch, it's a sophisticated computer that manages every stage of the charging and distribution process. The display reads 88.8V% off, and it features symbols indicating things like MCU control, set voltage, built-in timer, and full protect. Let's look at its 6 bottom terminals, marked simply with plus and dash. The left pair of terminals labeled as inputs from the solar panel array via the MCB is where the controlled solar power enters. The charge controller uses advanced maximum power point tracking MPPT logic, likely indicated by the MCU control icon. MPPT ensures that the controller is always drawing the maximum possible power from the solar panels, matching the fluctuating voltage of the array to the optimal charging voltage needed for the battery bank, regardless of the sun's intensity. This is far more efficient than older PWM controllers. The next pair of terminals on the charge controller are connected directly to the system's storage unit, the battery. In image_0.png, this is a large 12V 320 Ah heavy-duty battery. This battery is the central energy reservoir. During the day, when the sun is shining, the charge controller takes the power harvested from the solar panels and charges the battery. The charge controller doesn't just push raw power in, it monitors the battery's state of charge and temperature, using multi-stage charging algorithms like bulk, absorption, and float to prolong the battery's life and maximize its capacity. For example, it prevents dangerous overcharging, which can permanently damage or destroy a battery. The size of this battery is significant. A 320 Ah capacity at 12 V means it can theoretically store about 3.8 kWh of usable energy, calculating 12V320 Ah. This is a substantial amount for an off-grid system, able to provide backup power for extended periods when the sun isn't shining. Finally, the charge controller manages how electricity is used, which are the third pair of terminals labeled load. In image_0.png, this output connection takes the stored 12V DC power from the battery and routes it to your appliances. But first, it passes through another specific safety component, a second, smaller MCB labeled load. This provides a dedicated circuit breaker for your household appliances. Just like the main solar MCB, this load MCB protects against overloads or short circuits within your appliance wiring, ensuring the battery doesn't discharge uncontrollably. The load output from this entire system is at a regulated 12V DC direct current. This is perfect for powering devices designed for 12V operation, such as many types of LED lighting, specific water pumps, certain types of refrigerators, and even mobile device charging via standard DC to USB adapters. It's a highly efficient direct conversion of stored energy. The controller also features two convenient built-in USB ports, one marked as 2.1A, offering direct, high-current USB charging for phones, tablets, and other small USB-powered electronics without needing any external adapters. This entire setup works in a perfectly choreographed sequence. In full sunlight, the 750W solar array generates maximum power, which passes through the first MCB safety check. The advanced MPPT charge controller receives this energy, simultaneously using it to charge the massive 12V320Ah battery bank and provide steady power to the connected 12V household appliances via the dedicated load MCB. The controller's display keeps you updated on crucial metrics like voltage, battery state, and system efficiency. When the sun goes down, the load is automatically and seamlessly powered by the substantial stored energy reserve in the battery. It is a complete, reliable, and secure renewable energy solution designed for optimal performance.